Since we've ventured so far out along the branch of speculation, it's only fair to go all the way out and wonder if it will hold our weight when we consider the possibility of advanced super civilizations and what they might create. One of the interesting things about being a human being, about having sentience and self-awareness, or what the philosophers would call qualia, the crystallized form of sensory experience that's completely subjective and yet completely real. One of the singular aspects of this is the fact that we believe our sensory experiences to be real. Nobody can deny that. But reality is a concept that not just philosophers get to deconstruct. Once again, we're faced with extrapolation of capabilities that take us into interesting terrain. Just as life that's as advanced to us as we are to bacteria would be unrecognizable, look at the way we've progressed in the simulated worlds we create in our computers. All you have to do is look at the difference between computer games when they started 30 or 40 years ago and computer games now with their simulated rich three-dimensional environments, and the prospect that these games will be allied to technologies that tap into the brain, wirelessly perhaps, to induce senses beyond vision.
This will feel a little weird.
To create full sensory worlds out of pure computation. This is on the horizon, and it's more than just virtual reality. Where will this lead? Philosophers such as Nick Bostrom at the University of Cambridge have taken these arguments and possibilities seriously enough to pose something called the simulation hypothesis. This argument is based purely on probability theory and logic. There are suppositions involved, but you have to approach it purely logically. According to Bostrom, one of the following three propositions must be true. 1. The chances that a species at our level of development can avoid going extinct before technological maturity are negligibly small. For this, we should define technological maturity as the ability for a civilization to create synthetic entities. For this, we will define technological maturity as the ability of a civilization to create computational entities fully as complex and sophisticated as we think we are as biological organisms. So the first hypothesis says that species do not tend to get to this level of development. The second proposition is that almost no technologically mature civilizations, those that can create synthetic creatures like us, are interested in running simulations of minds like ours. And the third possibility or proposition is that we are living in a simulation, and we are simulated entities of some advanced creatures. It sounds bizarre, but logically one of these three possibilities must be true. Boiled down to its essence, the simulation hypothesis says that for every non-virtual 21st century human life, as you might imagine yourself, there are many more subjectively indistinguishable virtual lives. There's a very strong premise under this, which is a mechanistic premise that might be anathema to some humanists, called substrate independence. This is the hypothesis that what we think of as consciousness in the brain can be recreated computationally in silicon. Now that's obviously a great leap of faith. No computer scientist has ever demonstrated something like this. But we're only a few decades away from creating the level of computational complexity that parallels the electrochemical complexity of the brain, with its trillion neurons and 1,000 times larger of neuronal connections. That doesn't mean we understand the brain yet, nor will we in the near future. It's just speculating that in some indeterminate time, like a century or two, creatures will be able to create creatures of our sophistication and the subjective and internal sense of our rich and complex lives. If this can be done by any advanced civilization, it will be trivial in terms of time and energy cost to create vast numbers of virtual creatures. And by a Copernican type argument, the virtual creatures will vastly outnumber the true biological organisms in the universe. We can critique the hypotheses, but we have to accept one of them. The first possibility or proposition is certainly gloomy, but it might be true. It's possible that hardly any technological civilizations progress beyond our point, that technology at a certain level makes a civilization unstable. The second possibility seems on the face of it unlikely, because it would require commonality of purpose such that all the civilizations that could create complex entities like us choose not to do so. This is at odds, of course, with our experience, where we use our computers to create ever richer and richer virtual worlds in which we spend more and more of our time. If the first two hypotheses are false, then it only takes one or a very small number of super advanced civilizations to create so many synthetic creatures that the synthetic creatures outnumber the real creatures. And a priori, it's unlikely that we are some of the rare real creatures in the universe. At this point, you undoubtedly think of the movie The Matrix, which used elements of this hypothesis, which is an idea in philosophy. But of course, a super advanced civilization will create a matrix or a simulation that's essentially perfect. There's no way we'd know we're living in a simulation unless the simulators wanted us to know. This sounds off the wall, but let's just see what a short step it is from our current technology. Computer scientists have estimated the computational power that would be required under a mechanistic assumption of substrate independence that would be required to create the entire history of thoughts of all creatures like us, 10 billion humans over tens of thousands of years. The number of operations required is likely to be less than about 10 to the 30 or 10 to the power 32. It's a phenomenal number of computer operations beyond our current capabilities, but not so far beyond them that we can't extrapolate to it with 50 years of continued progress and the implementation of quantum computers. If, of course, this happens, we're faced with the possibility that computational intelligence will eclipse biological intelligence, and we will pass into what's called a post-biological world. If we assume that the exponential progression charted by Moravec will continue for another 30 to 50 years, we'll reach this point where harnessed clusters of quantum processors can create the computational power required to mimic the human brain in its full electrochemical complexity. The simulation hypothesis goes against the grain of our sense of ourselves. We think we're real, but of course, everyone will think they're real in a simulated universe, and your belief in your own reality is no better founded than anyone else's, and by that Copernican argument is most likely to be wrong. This would be a final and bizarre endpoint to the Copernican revolution, where the reality of biological lives is vastly eclipsed by the synthetic reality of computational lives. Astronomers like to think out of the box about what civilizations can do. Of course, sending radio waves and pulsing lasers through space represents our technology. SETI scientists are acutely aware that with our capabilities, we can only detect analogs of our own technology, and that's a transient technology. 100 years ago, we didn't have radio telescopes or lasers. 100 years from now, who knows what we'll have. Kardashev, a famous Soviet scientist from the 1950s, classified the capabilities of civilizations in terms of the fraction of the power of their star, or even their entire galaxy they could harness and use for their ends. We can continue the classification scheme of Kardashev and imagine that advanced civilizations would occupy themselves with pursuits that we can barely imagine, such as manipulating gravity and creating baby universes. The sobering reality, if we live in a universe where intelligence is propagated beyond our level, is that our exalted self-opinion may be taken down a few notches if we do finally make contact. Let's give the final word to Carl Sagan. Unfortunately, he died over a decade ago, but he was an iconic astronomer and astrobiologist who inspired a whole generation of my peers into the subject. He was also the first popular scientist and communicator who got across the incredible ideas of astronomy, cosmology, and astrobiology to a wider audience. He would have loved to live in a time where exoplanets and Earths were being discovered, and we were venturing towards the answer to questions we've asked for centuries.
I'm not very good at singing songs, but here's a try. If you wish to make an apple pie from scratch, you must first invent the universe.
network of wormholes. You might emerge somewhere else in space, somewhere else in time.
The sky calls to us. If we do not destroy ourselves, we will one day venture to the stars.
A still more glorious dawn awaits, not a sunrise, but a galaxy rise. A morning filled with 400 billion suns. The rising of the Milky Way.
The cosmos is full beyond measure of elegant truths, of exquisite interrelationships, of the awesome machinery of nature.
I believe our future depends powerfully on how well we understand this cosmos, in which we float like a mote of dust in the morning sky.
But the brain does much more than just recollect. It intercompares, it synthesizes, it analyzes, it generates abstractions.
The simplest thought, like the concept of the number one, has an elaborate logical underpinning. The brain has its own language for testing the structure and consistency of the world.
A still more glorious dawn awaits, not a sunrise, but a galaxy rise. A morning filled with 400 billion suns. The rising of the Milky Way.
The sky calls to us. If we do not destroy ourselves, we will one day venture to the stars.
For thousands of years, people have wondered about the universe. Did it stretch out forever, or was there a limit? From the Big Bang to black holes, from dark matter to a possible Big Crunch, our image of the universe today is full of strange sounding ideas.
How lucky we are to live in this time, the first moment in human history when we are, in fact, visiting other worlds. A still more glorious dawn awaits, not a sunrise, but a galaxy rise. A morning filled with 400 billion suns. The rising of the Milky Way. A still more glorious dawn awaits, not a sunrise, but a galaxy rise. A morning filled with 400 billion suns. The rising of the Milky Way. The surface of the Earth is the shore of the cosmic ocean. Recently, we've waded a little way up, and the water seems inviting.
The simulation hypothesis takes the ideas of astrobiology to the limit. It supposes that we can recreate the full electrochemical complexity of the brain and consciousness in silicon, in a machine, in a simulation. And the simulation hypothesis argues that it may be difficult to reject the hypothesis that we are indeed simulated organisms of some advanced civilization. If advanced civilizations exist that are as advanced to us as we are to bacteria, we can barely imagine their capabilities. But we are just a short few steps in extrapolation of our computational capabilities from being able to hypothetically simulate creatures like ourselves. We have to take the simulation hypothesis, however bizarre it seems, seriously.